in software engineering, we do test-driven development. Maybe you want to do performance-driven development where you are thinking about what can potentially go wrong with this piece of code. Performance engineering is the art of impacting the next line of code that the developer writes so that it is the best performing code and the best scaling code that it can be. Performance engineering is really all about building optimized systems.
You are listening to the Kubelist Podcast, a show interviewing project maintainers for CNCF Sandbox, incubating, and graduated projects. We'll discuss each project to understand where it came from and discuss the roadmap and plans to continue the project. Hi, I'm Marc Campbell. I publish the Kubelist weekly newsletter dedicated to Kubernetes and the CNCF ecosystem. I'm the founder and CTO at Replicated, where we enable cloud-native software vendors like Puppet, Harness, HashiCorp, Sneak, and many others to operationalize and scale the distribution of their modern on-prem software. Check us out at replicated.com. The Kubelist Podcast is brought to you by Heavybit, a program dedicated to helping startups take their developer products to market. For more information, visit heavybit.com. Finally, sign up for the Kubelist weekly newsletter and read previous issues at kubelist.com. Keptn is a sandbox project with an ambitious goal. On this episode, Andreas Grabner from Dynatrace joined me to discuss the origins and goals of the project. If you're unfamiliar with the Keptn project, it's a CNCF sandbox project that orchestrates workflows. Andreas explains the project in detail and covers some of the use cases, but Keptn is a pretty flexible project that can do a lot. Andreas talks about how they, at Dynatrace, were having problems with legacy Jenkins pipelines, but they didn't want to rip and replace them. So Keptn was born with a goal to integrate and reuse. This is a very practical approach to the problem, and one that I personally think is the right approach. I'm really excited to think about how Keptn can power a future of autonomous operations, which we discuss also. Self-healing automated runbook execution is a really fascinating topic. Let's jump in and listen to Andreas Grabner from Dynatrace explain Keptn. Hi, so I'm here today with Andreas Grabner. Andreas is a self-described DevOps activist at Dynatrace, the company behind Keptn, a CNCF sandbox project. Welcome, Andreas.
Hey, thanks for having me on the show. How are you doing?
I'm great. How are you?
Not too bad, actually. Yeah, it's early in November, as we just talked earlier, but people probably don't know. We talked a little bit about Christmas time is looming, Christmas markets, but unfortunately, this year, not a whole lot of Christmas markets.
Yeah, COVID's keeping us inside. So
exactly.
We're here today going to talk about Keptn, but I'd love to understand a little bit about your background before we dive into the project here. So can you fill us in on, your career, like what got you to where you are right now?
Yeah, sure. I started in 1999, just before the 2000 boom, I would say. I came out of high school and had my first job for 2 years. And then I actually made a career-changing move to start working for a company that was focused on performance engineering. So we built performance testing tools. And I started as a tester on a testing tool, which was interesting. I stayed there for 8 years. And it got me hooked on performance engineering. And then after the 8 years, I followed my CTO back then in the first company because he founded Dynatrace. And 2 years into his journey of Dynatrace, I followed him over. And I've been with Dynatrace now for 12 and a half years. And I've been always having like an evangelist, DevRel role, really helping our customers at Dynatrace. But I think more the general market to understand the power of monitoring, the power of performance engineering, if you are using it strategically in your software delivery lifecycle to speed up delivery, to bring better quality software to the market. And so, big background in performance engineering and now doing a lot of work on monitoring, observability, and in the last 2 years, heavily involved in the Keptn open source project.
Great. And I think, a lot of us in the Kubernetes world are familiar with monitoring and observability, but you brought up a term performance engineering. And you actually have your own podcast kind of talking about some of these concepts too.
Yeah.
Can you help explain what the scope and what performance engineering means?
Yeah, good question. So, the podcast is called Pure Performance, in case anybody's interested in listening in. And one of my mentors in life, Marc Tomlinson, he came up with a great quote and he said, performance engineering is the art of impacting the next line of code that the developer writes so that it is the best performing code and the best scaling code that it can be. So basically, he differentiates between performance testing and performance engineering in a way that testing means you're testing an existing piece of code and then you're throwing back the results, while engineering is more holistic, where you say, I'm going to show you and teach you how you can become a better engineer, a better developer, a better architect, because I help you understand the dynamics of your system, the scalability aspects and the performance aspects. And so performance engineering is really all about building better scaling, better performing, optimized systems.
That's great. Kind of thinking about performance before you're actually monitoring and observing it, thinking about it like the way you think about security when you write code, make it a first principle.
Exactly. Yeah. Like in software engineering, we do test-driven development. Maybe you want to do performance-driven development where you are thinking about what can potentially go wrong with this piece of code. What's the performance impact if I'm adding in this new library, or if I change the way I access my database, or if I am loading this particular piece of resource file uncompressed versus compressed. I mean, there's a lot of different things that we've learned over the years, patterns. And so, yeah, we want to educate engineers to think more about performance right before they start writing the next line of code.
That's awesome. So let's dive into the Keptn project, what we're here to talk about today. Can you kind of start us off, just kind of explain what the project's doing?
Yeah, sure. So if you go to our website, keptn.sh, hopefully it does a good job in explaining what it does. Basically what it does, it automates the configuration of monitoring, observability, alerting, delivery, and auto remediation of an artifact throughout its life cycle. So basically what we are doing with Keptn, we saw that there is a need in rethinking how delivery of cloud native application works and rethinking how operations works for cloud native applications. And Keptn provides a new event driven approach where we are using a declarative approach for defining your workflows and processes for delivery and operations. And we're using an event-driven model so that every tool that you want to use in your lifecycle can easily participate in that workflow without having to hard code them into your delivery pipelines or auto remediation workflows. So with Keptn, we are addressing pains that we have seen within our organization, but also pains that we've seen with companies we work for that all realize that, hey, we're all moving now to Kubernetes. We're all moving to containers. We are deploying them much more frequently. And while we all know how Jenkins works for delivery and while we all know how runbooks work in operations, it feels like we need a new approach to allow us to scale this, because we are talking about a different scale of how many moving pieces we have in modern software architectures.
That's cool. I think I get it. I think one thing that helps me kind of understand some of these newer concepts is like a more concrete example. Is there like a really simple concrete example that you can provide of where Keptn is able to solve a problem in the Kubernetes native world that we can grasp onto?
So I think the challenge we have when we started with Keptn, we initially focused on continuous delivery there, but then we also focused on, we call it continuous or automated operations. So Keptn covers a lot of ground. It really manages the whole life cycle of an artifact. That's why we always have a little challenge to describe or to give Keptn a name. What does it do? It's not just doing CD. It is not just doing operations automation. It's doing a lot of things. But the great thing about Keptn is you can make it do things that level up your current processes around delivery and around operations. So to give you a concrete example, because this is kind of also what drove this within our organization, focusing now on actually continuous delivery first as an example. When we moved as an engineering organization from, let's say, more traditional monolithic applications to container-based architectures, we obviously, for delivery, chose the tools that we were familiar with. Right? We chose Jenkins because that's the tool we've been working with for years, and we had our pipelines that were deploying our apps. And these pipelines were obviously integrated well with the tools that we use to deploy. So if you look at a classical delivery pipeline, you have your build, you have your deploy, you have your test stage, all in that pipeline, and you have your different plugins of the CI tool of choice, like in our case, Jenkins, that then talk with the right tool to build, to deploy, and then to run some tests. It's all kind of hard-coded in that Jenkins pipeline. And then we saw that we kind of took these pipelines, and we adapted it to microservices. Worked well. More services were onboarded, more projects, more teams started to build microservices, and they all kind of said, hey, you guys already have a Jenkins pipeline over there for deploying containers on Kubernetes? Sure, I'll take yours, copy paste, maybe do some slight modifications. And then over the first couple of months and years, we realized, wow, we started with one Jenkins pipeline for one microservice that was kind of a little hard-coded with Helm and then with JMeter as a testing tool. And we saw that we had many copy-paste versions of the Jenkins pipeline because every tool, every project had their own little nuances and requirements. So we ended up with many snowflakes of these Jenkins pipelines. And now we had got the requirement, hey, we need to switch tools for testing. We need to switch tools for deployment. Then we said, well, where do we even have all these tools? In which pipelines do we have them? It's very complex to manage. So it took a long, long time. So we said, you know what, if we have this problem, then I'm pretty sure we have a lot of other organizations that have the same problem of hard-coded, we call them monolithic pipelines. Monolithic pipelines because they came out of this monolithic world. And so we said we want to solve the biggest problem here, which is actually the separation of concerns, which is what is the process of delivery and what are the toolings that are used. Because in the Jenkins world, everything is kind of hard-coded in this particular file. So the problem that Keptn solves is exactly this. What Keptn does, it gives you the option to define a process that defines how you're moving an artifact through the different stages, what should happen. So you just define what should happen in each stage and how many stages you have. And then you have another team that can define which type of tools provide capabilities that can participate in that workflow once that workflow is executed. And just as in modern software architecture, where you have microservices that communicate with each other, they communicate through eventing. So also Keptn at its core has an event engine. That means when Keptn orchestrates a workflow, like a delivery workflow, it sends events that basically say, I need somebody or some tool to execute a certain task in my current process. And then you can have one or multiple tools that provide that capability. They react to that event, and then they raise their hand virtually, obviously, and say, I can do the deployment. I can do the testing. I'm actually the tool that has been kind of chosen for this particular environment to do the testing in our organization. So let me do it. And this clear separation of concerns, this event-driven model, gives us a lot of flexibility because we can change the process at any time. So if our organization decides, besides having dev, staging, and production, we also want to have an additional security stage where we do additional security testing, then we just change the process definition. And we don't have to worry about all the tool integrations that are hard-coded anywhere. On the other side, we can easily switch from one tool to another without having to figure out where are the hard-coded dependencies to all of our pipelines. And that's one of the problems that Keptn solves. So it allows us to easily adapt and change process and tooling. They can be done by different teams because typically there are also different teams within an organization that define the process and the tooling. It's all event-driven. It's all based on cloud-native events, which are standard. So that means everyone can easily also integrate their own tools. It's all standardized. It's an event-based system. We're obviously using tracing to trace all these events. So we actually have a full audit of what is happening at any point in time. And obviously everything we also do is Git-based. That means every configuration file that is changed or that is needed by any tool that participates in that process is also storing this file or making changes in Git, so everything is completely version controlled.
Okay. That is a big and really interesting problem. And I'm sure it's actually useful even as you scale an organization or scale a project, right? Like if I don't have the need for all of these different workflow steps, adopting Keptn early allows me to easily insert those as the organization grows.
Exactly, and thanks for bringing this up. I know this was a lengthy description basically on the architecture and the separation of concerns, but you're right. I mean, in the end, I described the full end-to-end delivery process, right? Like multiple stages, deploy, test, and validate. The entry point use case that we currently see about 80 to 90% of our users adopting is actually one key capability of Keptn that is used in delivery, but that it can also use standalone, which is what we call an SLO-based quality gate capability. So part of the delivery process, right? Remember I said deploy, test and evaluate. And the way Keptn does the evaluation, it reaches out to your monitoring and observability tools, to your testing tools, to your quality tools, to your security tools, and basically pulls in indicators, SLIs, service level indicators, like, what's the response time? What's the memory consumption? Do we have any new vulnerabilities? What's your failure rate of the last test execution? So it pulls in all these metrics, again, event-based. It reaches out to these tools by sending an event, and then all the tools that say, yes, I have some data for this environment where you need data, they basically respond and say, I have these 5 data points. And then Keptn takes this data and then compares the values against your objectives. So we have been using the same principles that Google has been spearheading with their SRE best practices around SLIs and SLOs. So what Keptn does, it automates the collection of key metrics, SLIs, and is then comparing them against the objectives that you as a Keptn user also declare or write down in a YAML file, which again are version controlled. That means they typically live next to your source code so that every developer can say, here are my SLIs that I want, here are my SLOs. And every time I now want to ask Keptn to validate my software that is currently running somewhere and that is monitored by some observability tool, then Keptn can automate the capturing of the data and comparing it. And this use case, again, it's very embedded in continuous delivery and also in automated operations in Keptn. You can also use this standalone. And to your point, this is really what helps our users to say, well, you know what? We don't want to replace everything end to end. But what we want to do is we want to, let's say, take our existing delivery pipeline that works well for us because we can deploy and we run some tests. But what's missing right now is this event-driven, automated evaluation of a quality gate. And a lot of people are kind of catching on SLIs and SLOs. So when we use these terms, people are familiar with them already. Many organizations have already defined SLOs in their production environment. So we say, it's great. If you already know what defines the success of your software in production, why only look at this in production? Why not shift left and let Keptn look at these SLOs and maybe some additional ones that are more interesting for you as engineers? Let Keptn automatically monitor those, evaluate those, and give you a score, a quality score, a quality gate score every time you run a build through your existing pipeline. And with this, we automatically level up your existing pipelines by giving it this automated validation step.
Got it. So many questions right now about how you actually are able to do that. Like, let's start with based on the outcome of that validation score, like you mentioned, it goes through the deploy, test, evaluate phase. Like, is that where it ends and it leaves an event that I can then take an action based on that score? Or does Keptn also have the ability to hook up remediation or some next steps to the process?
Yeah. So if you're just using the quality gate capability where you say, hey, Keptn, you go off, you analyze my SLIs and my SLOs that I have defined here in my Git repository, and you analyze them on the system I just deployed for the last 30 minutes because that's when I ran my tests. Then Keptn will launch a process, launch a workflow, an event-driven process. And at the end, it tells you, I got your result. Your result is 90% score, because we always come back with a 0 to 100%, right? So that means you can use this in your existing pipeline, and then based on that number, you say, okay, my pipeline continues. Now, if you use Keptn for continuous delivery, like the whole end-to-end workflow where Keptn can orchestrate the delivery and the testing and then does the evaluation, then Keptn actually takes that evaluation result and says, all right, we've just deployed in dev. We ran the tests. We got a score of 95%, which based on your process definition allows us to automatically promote this to the next stage, which depending on your process definition might be staging. And then Keptn would automatically continue that workflow and say, hey, we have a new artifact. It just comes out of dev, has a 95% quality rating. Now I need somebody that can deploy this into the next stage. Once this has happened, the test happens in that stage, and then the evaluation again. And so the process continues. So yes, Keptn uses this quality gate information as part of the delivery process. If you use Keptn for the full delivery process, to either stop the process or let it continue to the next phase. It also, and to answer, I think the other point you were alluding to, Keptn can also instruct a delivery tool based on your process definition to, for instance, do a canary deployment. Hey, when we get a new version out of dev or staging, we want to do a canary deployment of that new artifact in production with 10% traffic. And then Keptn can actually say, well, I have just initiated the deployment. Once the deployment is done, this can be done by the built-in capabilities of Keptn. Keptn can also talk to Argo for Argo rollouts. Keptn can also talk to Flux or Spinnaker. So Keptn is, as I said, event-driven, so you can actually use any type of tools for the actual delivery action. But what then Keptn also does, once the deployment happens and you run your canary in production, then Keptn again enforces the quality gate and says, hey, we just deployed into production. We have a canary release. Now I want to tell you that your score is below your accepted criteria. Let's say your score is only 50% on your canary. And then Keptn can say, based on that information, I know that you in your process said you want to roll back or you want to turn off that canary. So then Keptn would automatically send another event to say, let's scale down that canary or take it out. Or it could also happen the other way around. It could say, we got 100% quality of this new canary. Maybe we want to scale up and add more traffic to it.
A lot of what you just described there is like really heavily around like the integrations that Keptn can integrate into other ecosystem products. Mm-hmm. You mentioned Argo, Flux, Spinnaker. A lot of like the progressive delivery and rollout is like starting to be covered more and more with SMI and service meshes, Linkerd, Istio, in that integration. Can you describe a little bit like how Keptn integrates into service meshes if I already have one running in my cluster and already have that process?
Yeah, so I think again it comes to the actual delivery tools, at least as far as I see it from my perspective and my knowledge of all of these progressive delivery frameworks. From the Keptn perspective, if you install Keptn, we deploy what we call the Helm service. So we're using Helm. We have a service that can listen to the deployment requests from Keptn and then can deploy a Helm chart. And if you are onboarding a Helm chart for your service and in the process definition you specify blue-green, we actually assume you have Istio, and then we automatically configure your virtual services and leverage service meshes for the actual blue-green deployment for the traffic switch. Now, the same is obviously true if you are using tools like Spinnaker or Flux or Argo, right? So these delivery tools will then deliver based on your, let's say, rollout definition, and then use to do this technically your service meshes that you have. So I think what we see, instead of having Keptn from a delivery perspective integrating with a service mesh, which obviously would make sense, we see right now more Keptn being integrated with your specific delivery tools that can provide a canary deployment, and then depending on how this tool does the canary deployment, may use as Istio or whatever service mesh you have. So hopefully this answers the question a little bit.
Yeah, I think that does. I think the next question that I have really around that is like integration into legacy tools. You mentioned a little while ago that Keptn is using the cloud native events. Mm-hmm. And so I'm guessing like a lot of that was done in order to provide compatibility with the massive ecosystem of tools that existed before Kubernetes. Like if I have a legacy tool, Jenkins you mentioned, mm-hmm. and Spinnaker is obviously, like a modern tool. But what about like really old legacy tools? Like what's the effort that I have to go through in order to integrate one of those into a Keptn workflow or pipeline?
Mm-hmm. So the effort is actually, if you know how to build a container and if you know how to build code that can listen to an HTTP post event that contains a JSON object, then you're halfway there. So the way this works is Keptn, as I said, sends events to ask basically your tools, we call them Keptn services, hey, who can do the delivery? And for instance, Jenkins is a good example because we already have an existing so-called Jenkins service. That means if you are adding the Jenkins service to your tool belt of Keptn, that Jenkins service is then actually listening to a deployment request. And what it does, the Jenkins service itself is a very small, basically, proxy container that is receiving that event. And that event then contains information about which Keptn project, which Keptn service, which stage, some additional metadata about what type of deployment should happen, information about the artifact that should be deployed. And then this service can then, like in the Jenkins example, just makes a REST call to the Jenkins API to trigger a job. And that job, again, is obviously needs to be configured. Which job do you want to execute? And this is where every Keptn service that you develop, whether this is the Jenkins service that we just mentioned, or maybe a service that you write for even another, let's say, older legacy tool, every Keptn service that participates in the workflow when it gets triggered to an event also has full access to the Keptn configuration repository, which is the Git repository that I mentioned earlier. So that means as a Jenkins service, I can say, hey, Keptn, please give me my Jenkins configuration file. So the way we did it with the Jenkins service, you can upload a so-called Jenkins conf.yaml file where you can say which Jenkins job should be executed with which parameters if a certain Keptn event is sent. So this is basically a very easy way to call any Jenkins pipeline based on any type of Keptn event. And if you want to build your own service, again, the only thing you need to do is build a container that can listen to HTTP requests and then understand and be able to parse cloud native events. We have templates for that. We also have a tutorial out there, and I think I've recorded a video where within 5 minutes, you can write your own Keptn service to integrate any type of tool. And the template is so easy. You just, you clone that repository, and the only thing you need to do is you need to fill in the code in the event handler for that particular event that you want to handle. So you need to know a little bit of coding, but you can decide which language, whether this is Go, which is one of our preferred languages, but you can also do it in Python or in any other language.
But at the end, it's just kind of some glue code that I have to write.
That's all it is, yeah.
That's cool. Let's switch gears for a minute and talk about the tech stack that you're using for Keptn. Like, can you describe what languages, what frameworks, what tools you're using to build it right now?
Yeah, sure. So what we primarily, everybody can go to, obviously, to our GitHub page, so GitHub Keptn, and then you see that's the Keptn core project. And I would say primarily we have Go there as the primary language for all of our core Keptn services. There's obviously some Angular, some JavaScript for our bridge, which is our UI, but it's primarily Go. We have some Python in there. We also have the Keptn contrib organization. This is for contributor projects. These are projects that are, I think, Prometheus integration, the Dynatrace integration, the Neotis integration. These are all, let's say, Keptn services that have been around with Keptn almost since the beginning. They also kind of represent key integrations of Keptn to work correctly, like obviously with Prometheus as an observability platform, also JMeter, that's also part of this because of for testing. And then we have the Keptn Sandbox, which is where all of the new Keptn services that are implemented are kind of starting their life. And then, once they get more popular and you have a certain adoption, then they move to contrib. I believe that some of our contributors are using Java as the language of choice. We have, I think, a small number of Python contributions where people just wrote Python, as you called it earlier, glue code services. But the core stack from our end is definitely Go. And maybe some other, I think you asked about frameworks. So Keptn itself, when you install it, you get our event bridge, our remediation service, our Shipyard service. These are all the core services we have. Then we have Nets as an eventing engine because Keptn, uses events, as I mentioned. And we initially we were using 2 years ago when we started with Knative as an eventing engine, but then we switched over to using Nets and really then forward these events to our individual containers that subscribe to these events. We also have Mongo in there as a data store. We have one service that's called the configuration service that holds the Git repository. And I believe that's a good overview of the stack.
Cool. I've been kind of looking through the docs here and the architecture, and I think I'd love to double click on the Shipyard service for a minute and understand a little bit more about what that does. It seems like it's a pretty critical part of the system.
Exactly. So remember when I said Keptn separates the concerns between processing and tooling?
Right.
So the Shipyard is really the service that is orchestrating the process, because we call the process definition the shipyard file. So when you define your delivery process, where you are saying I have dev, staging, and prod, and in dev I want to do direct deployments with, let's say, some basic functional tests. And then in staging, you have, let's say, a blue-green deployment and you run some performance tests. And then in production, you're doing a canary deployment and you run some real user tests. So this is basically the process definition. And you define the process in a so-called shipyard file. That means every time you're creating a new project in Keptn, so Keptn is project-based, every time you create a project, you create that project and give it a shipyard file that describes the process for delivery. And the shipyard controller is really as you said, it's the heart. The shipyard controller is the orchestrator of that process. So every time I send an event to Keptn and say, hey, Keptn, I have a new artifact for you. I want you to launch that process that I've given you or described to you in the shipyard file. Then the shipyard controller takes over and says, I know what to do first. First, I need to take your new artifact version that you just gave me and make sure it ends up in the configuration repository to update your Helm charts. Then I will send out an event for the deployment. Once the deployment is done, it sends out the event for testing. Once testing is done, it sends out the event for the evaluation. And then based on the evaluation result, it then sends out the event to either promote this artifact into the next stage or stops the process and alerts people. So it's a very critical component. You're right.
Cool. I'd love to dive into the roadmap. Like Keptn is at version, like 0.7 right now at the time that we're recording this?
Exactly. 0.72, 0.73 should be released next week as the time of the recording. Yeah.
Cool. And I'm curious what you're working on right now, like what we should be looking forward to in the next, few releases.
Yeah. So another big move is going to come with 0.8, which is targeted for the end of the year, at least as a beta version. And right now, what we have when you install Keptn, and I told you about these services that are actually subscribing to the events and then executing. So right now, as of 0.7, these services have to be deployed on the same Kubernetes cluster where Keptn runs. That means all of the control plane and the execution plane live on the same cluster. Now with 0.8, we're changing that, where you can install the Keptn core components like the shipyard controller and the remediation controller for auto remediation and all the other core components. You can install them on, say, on a Kubernetes cluster, and then the execution plane, the individual tool proxies or tool integrations, they can then be installed on other Kubernetes clusters, even on other remote systems that don't have to be Kubernetes based. So this then allows you to say, I have a central Keptn control plane, and when Keptn is orchestrating a process for delivery, it can actually then execute these external tools, not from within that Kubernetes cluster, but from anywhere where you have your execution plane installed. And that's a big change for us.
Yeah, that is actually really cool. I think, we're seeing a lot more of that in like the Kubernetes ecosystem in like a lot of CNCF projects, the multi-cluster support.
Mm-hmm.
We was just talking to like the folks at Linkerd, and like they've introduced some new support for that recently. Kind of diving into that for a minute, like how does eventing work when I have multiple clusters running? How does Keptn handle that communication?
So today it's very easy, right? Because basically when you are deploying your Keptn service, and let's take the Jenkins service as an example, when it starts up, it basically subscribes to the events of the Nets eventing bus in the same cluster, and that's easy. Now, obviously, this won't work anymore once we install the execution plane outside of that Kubernetes cluster, because you probably don't expose that to the outside world, and everybody can just register. So we will have a polling mechanism. That means you can install your execution plane, let's say again Jenkins, on different machines, and when you launch them, then they will register themselves on Keptn and basically say, hey, I'm here. This is my metadata. I am the Jenkins service for this particular type of environment, and I have these and these capabilities, and I'm interested in these types of events. And then this execution plane, this Jenkins service, will then constantly poll and basically ask, hey, Keptn, do you have new events for me to act upon? And once there is an event, then Keptn will forward it. And then what's important, a tool like a Keptn service, like the Jenkins service, will then need to tell Keptn by sending an event back to Keptn that it actually starts executing the action. So asking for, is there an event that I'm interested in, is one thing. But then if the execution plane then decides, yes, this is actually something I'm interested in and I can do it, it then sends back the start event. So it says, hey, I'm starting the delivery now, which tells Keptn who is working on this actually. And it can then also obviously refuse and coordinate between multiple services that maybe try to do the same thing. But it also tells Keptn, hey, somebody's working on it. So I'm also expecting a final result once that task is complete, which means the execution plane eventually also needs to send a finished event with a final status, successful or failed. And the reason why we need these events, obviously, is because then Keptn needs to control the workflow. And eventually, if one of the tools says, I'm doing this, but never comes back, then we have the opportunity for timeouts and for retries and things like that.
And that's in 08 coming at the end of the year. Is that something that Dynatrace needed and kind of drove that, or was that more driven from the community?
I think it was more driven by the community, where Dynatrace itself is also part of our community, because we are, while the core engineers or the core contributors of Keptn are Dynatrace employees, we see also Dynatrace as a user of Keptn, right? So that's why I'm saying they're also part of the community, and therefore are also driving requirements and future improvements. But the remote execution was, while it was also driven by Dynatrace internally, it was more driven by our adopters. And actually, it's funny that we started down on the Jenkins train. Jenkins was one of the reasons they wanted Keptn to orchestrate the end-to-end delivery process, but still want to use their existing Jenkins pipeline, for instance, for deployments, because they have obviously a great Jenkins pipeline that they have built over the years, and they don't want to throw this away. So that's completely fair to then let Keptn orchestrate the end-to-end workflow, but then call Jenkins pipelines for individual tasks. The other big use case where the remote execution was demanded was for the auto remediation piece. Because so far, we focused on delivery, right? Keptn can orchestrate the delivery process, but the second big process that Keptn orchestrates is auto remediation, meaning if you are monitoring an alerting tool, is detecting a problem and then sends an alert or a problem to Keptn, Keptn can then take this problem and can then look up a defined remediation workflow. So similar to a delivery workflow where you say what should happen in each stage, the remediation workflow in Keptn says basically, if this problem comes in, you try this action. If this doesn't work, then the next action and the next. So you basically specify a list of actions. And actions could, for instance, be, let's say, Dynatrace detects there is a rogue process on some remote machine eating up all the CPU and therefore impacting a critical service that also shares this particular host. So Dynatrace can send this problem to Keptn, and then Keptn says, hey, for a rogue process, I have a remediation workflow. And it basically says something very simple like, restart that process or kill that process. But in order to do this, you obviously need to have access to that remote machine. And therefore, we need to have Keptn services that can then execute these remediation actions also on remote services. And this was a big ask from a couple of large enterprises that wanted to really look into using Keptn for automated remediation. And I think to finish this, why they're looking into Keptn, because Keptn is not only doing a fire and forget. So it's not that you send Keptn a problem and then it executes action 1, action 2, and action 3. What Keptn does, it executes the first remediation action, then it evaluates the state of the system by, again, using our SLO approach. So it, again, reaches out to your monitoring tools and say, hey, we have a critical situation in this particular area based on this problem. We just executed remediation action. So now, after we've done this, please give me the current state of the system by pulling in your critical SLOs. And if the system is back to a healthy state, that's great. Then we know the remediation worked. If not, then execute the next action. So it's this, we call it the closed loop remediation. We always execute an action and then validate. And if this didn't, the validation says the system is still in a critical situation, then we can execute the next action and keep trying until we've kind of worked through all the process. And if nothing works, then in the end, obviously, we can escalate to a human being, for instance.
Yeah, that's such a powerful concept there. I think, like it's definitely worth chatting a little bit more about like these SRE processes. You mentioned the Google SRE handbook,
Mhm.
like taking that and like allowing me to build completely automated runbooks that operate completely on their own. They're autonomous systems. I don't have to have a team of SREs who understand here's the runbook to apply, but this many to many kind of action that Keptn orchestrates. Dynatrace has great first class support in Keptn, I'm sure,
Mhm.
but like not just limiting it to that, being able to receive inputs from everywhere, and the closed loop is really cool.
Yeah, exactly. Yeah. And I think another important piece to this discussion, and I told you that we have our podcast, Pure Performance, and we just talked with Anna Medina from Gremlin. She's a chaos engineer over there. And we talked about the interesting aspect of we all try to educate people about auto remediation in production. So basically, we're executing code in production in this case, in terms of Keptn is orchestrating a process and therefore triggering actions which are basically our code. But while this is obviously the desired state where we want to get to, it's also very scary if you think about that you're deploying remediation code into production and may have never tested it before. So that's why we believe if you take all this and shift it left and start thinking about test-driven operations, which means when you have an engineering team that should be responsible end to end for their services, they obviously need to write great code. They should write great tests for their unit test coverage, their functional test coverage, their performance test coverage. But if these teams are also responsible for operations, they also need to write these remediation scripts or these remediation workflows. For instance, using Keptn as the orchestrator and then individual actions that can then do things to bring the system back to a healthy state. But how do we test this? The way we can test it, I believe, is as part of a delivery pipeline, deploying your new code, putting it on the load, and then enforcing chaos to simulate a chaotic situation. And with this, also test if your remediation code actually works as expected. And I think that's the thing we also need to get into the heads of all the site reliability engineers that want to enable their engineers to kind of take more ownership and responsibilities, because this has to be built into the delivery pipelines, because you should not deploy something in production that has not been validated against the SLOs, but also that has not successfully made it through chaos tests where you've also tested the remediation workflows.
Yeah, I think, you'll be hard pressed to find an SRE who doesn't really want to automate everything. But like to get to the point that what you just described, the long-term vision of like these complete automated workflows, it requires a high amount of trust in the process and the tools and the code. Like you're going to go to bed at night and you're going to wake up in the morning and potentially there's different things running in the cluster than when you went to bed.
Correct. Yeah, no, I agree with you. I mean, I know I'm preaching now, right? Kind of like, yes, this is what you should do, and why doesn't everybody do this already? But I understand that it's easier said than done. But we have to have a vision. If we don't have a vision, if we don't give people the ideas on where we need to go to, then nobody would improve. So that's why I strongly believe that we all need to automate, but when we start automating operations, we also need to think about the quality of that remediation code in production. In order to ensure quality, we need to test it. That's why I believe test-driven operations, which means integrating your remediation workflows in a test batch in pre-prod, where you are deploying your code, putting it on the load, and then enforcing chaos, and then see if your system actually makes it through that chaos fully automatically without negative impact on your SLOs. Then you can go to sleep at night and not waking up with nightmares.
Yeah. Let's dive back into the community side for a little bit here. With 07 out, 08 coming out, Keptn is currently a sandbox project. Is there a particular use case that you're looking for, or what's the best way for somebody in the community to engage that provides a lot of value to you right now and helps advance the Keptn project and vision?
Mm-hmm. Well, there's several ways to contribute, right? On the one side, when you go to the Keptn Git repo, you will find a lot of issues that are labeled with a good first issue. So if you really want to contribute code and you want to help us implement features or fix bugs, then you're very welcome to have a look at our good first issues on the Keptn Git repo. We have been involved in the Community Bridge program, where we got a couple of people that helped us with actual contributions. It was great from the CNCF side. We also been part of hackathons, October Hackfest. So there we typically started with these good first issues. I think that's one great way. The other great way to contribute is, if you look at Keptn and you have your tools in your organization and you say, well, I wish Keptn would have an integration, you know what? Start building your Keptn service for that tool. That would be great. We also have a couple of issues, open issues on the Git repo, like where we said, hey, we would love to see integrations with tool XYZ. So for instance, we have, obviously I'm representing Dynatrace, but we have issues there to build integrations with Datadog or New Relic. That would be great to see. It would be great to see some better integrations with Spinnaker and some other tools. Selenium often comes up as a testing tool where we would love to see contributions. So if you're familiar with these tools and you like what you hear with Keptn, then build that. The other thing what you can do is you can start joining our community meetings that happen every Thursday at 5 p.m. Central European time, which I know is early in the morning on the Pacific side, 8 a.m. or about it's 11 a.m. Eastern. That would be great. And the best way also to get just a feel for Keptn, if Keptn is something for you, go to our website or go to tutorials.keptn.sh and give it a try and give us feedback on the tutorials, on the website, on the documentation, because we know we can always do better. And I'm sure there's mistakes or things that are unclear. So feedback is welcome. And the best way to give us feedback is either through issues on the Git repo or join us on slack.keptn.sh and just let us know through the Slack channel.
The Keptn project makes a lot of sense right now to me. If I want to get started with it, do you have any recommendations for best practices on how to maybe carve out a small way to get started that's not as overwhelming as trying to orchestrate an entire pipeline end to end?
So again, I have to give you multiple options. But if you go to the tutorials page, they all walk you typically through end-to-end use cases. Also on the delivery side, but we use our sample apps. So the only thing you really need is either a Kubernetes cluster where you can then deploy Keptn to, or, and I think this is a great thing that we have invested in, if you don't have Kubernetes experience or for whatever reason you cannot get to a Kubernetes cluster, we also have tutorials using K3S, the lightweight Kubernetes distribution from Rancher. So there's also tutorials on that. The only thing you need is a Linux box, basically, with one vCPU, 4 gigabyte of RAM, and then you can walk through the tutorial that shows you quality gates, that shows you delivery and auto remediation. So yeah, check out the tutorials. And also there's tutorials for Prometheus, there's tutorials for Argo, tutorials for Dynatrace, and plenty of things to get started.
Great. And then, it's a sandbox project right now, Keptn is. Has the team given any thought to milestones or timelines in order to move up to an incubation phase?
Yeah. So actually, we just had our first Keptn advisory board meeting yesterday, and we had folks on the advisory board that also asked the same questions. And yes, there's a clear goal for us to move to the next stage. And the goals are more adoption. So one of my personal goals is that I increase adoption, not me knowing that I know that people are using Keptn, but actually on the Keptn project, we have an adopters file where we keep track of adopters that are allowed to say or that they want to say that they're actually adopting Keptn. So this is one of the measures that we have, public adoption of Keptn and referenceable adoptions. And the second thing that we learned yesterday in the advisory board, we need to grow contributors and we need to grow the people that are participating in our regular community meetings. Because while we've been doing this for a while, we still have not the numbers. We still are low in attendance there. Because I know there's a lot of projects out there. A lot of projects try to do the same thing. So we're all fighting for the same people. But yeah, these are our goals: contributions and adoption.
Yeah, I think that's great. I was just taking a look at the adopters file right now. And it's really hard because, when you're writing these open source projects and putting them out there, there's definitely adoption happening, that it's running behind a firewall. They're not sharing that they're adopting it, which is great that they have the ability to do that. But it's really hard to kind of get a handle on the full breadth of the adoption.
Exactly, because like if you look at the adoptions file, there's a handful in there, but I'm personally working with about 50 different users in different organizations where I know they have it running, and I'm pretty sure the gray number is much higher because I don't know every Keptn user out there, even though I try to keep track of it, but it's impossible, as you say. So the number is much higher, but we just want to have more people officially declaring that they are actually using it, because this helps us with the CNCF status. And it's also a great feeling for the core engineers that they see who is officially using it.
Cool. So right now, some takeaways for me are, get Keptn installed, have it wired into our Kubernetes clusters. Go check out the latest episode of the Pure Performance podcast, with Gremlin and Chaos Engineering integrations. That sounds like super interesting.
Yeah.
What other takeaways or topics do you that are worth bringing up that we haven't chatted about so far?
I mean, you did a great job in asking all the right questions. No, I think there's not a whole lot more to add other than every project like this lives through the feedback and the community. So we need to grow, but the question is, what do we need to do in order to grow? Do we need to, are we building the right thing? I think that's the most important thing. Are we building a thing and are we solving problems with it that really need to be solved? So, and I think the easiest way to answer this is your organization maybe looking into ways to optimize your current delivery or your way and approach to automated operations. And I'm not talking about replacing things that you have. We don't want to rip and replace, but are you doing automated quality gate enforcement? Do you have an approach for automated operations, meaning for automated remediation? Or are you looking into this? Are you building something yourself? Because this was actually one of the things that initially triggered us when we saw we needed a new tool. We had a meeting, it was 2 years ago, we had a big event, and actually my boss, Alois, he was in a roundtable meeting with 50 CIOs, and he basically asked the question, who is trying to figure out what the next generation of delivery and operations looks like in your organization on your new cloud native platforms? And everybody raised their hand. So everyone was already starting and thinking about building this new platform or have already built it. So the question is, why are all of you building the next generation platform? And why don't we have an open source tool that tries to standardize on how the future delivery and operations look like? And I think this is why we also think that Keptn will take off, because we know there's a pain out there. We know there's a need. And instead of everybody having to build their own thing, we want to be the one that is building the core platform. And by keeping it so open, we can integrate with any type of tool that you have. Because again, there's a lot of great tools out there. We don't want to rip and replace them, but we want to orchestrate the end-to-end delivery process and the automation in operations.
Yeah, Andreas, I think that's that message just shows how much effort was been put into the thought in the implementation here at Keptn. It's easy to build something to rip and replace, to modernize, but to orchestrate and coordinate legacy and modern tooling to give me a really good workflow is definitely not the easy path here. And I think Keptn looks like it's doing a great job of it. So I'm excited to give it a try.
Very cool. Yeah, and give us your feedback, right? If you run into any issues, slack.keptn.sh.
Yeah.
That would be great, yeah.
Awesome. Andreas Grabner from Dynatrace, and one of the creators of the Keptn project. I definitely appreciate the conversation here today. Really excited to see what the next steps are for Keptn.
Yeah, thank you so much. And thanks for giving me a chance to talk to your audience. And stay safe and healthy.
That's all we have time for today. If you're the maintainer of a CNCF project and would like to be a guest on this show, head over to Kubelist.com. To learn more about Heavybit, visit Heavybit.com to check out the library. It's packed with amazing talks and content on sales, marketing, product, and more for founders of developer tools companies. And this podcast is brought to you by my company, Replicated, where we enable cloud-native software vendors to operationalize and scale the distribution of their modern on-prem software to their largest enterprise customers. Check us out at Replicated.com.